Okay, so crude oil part 2. What we've got is we found out that fractional distillation is used to separate the hydrocarbons. So we get all those separate things, like we get separate sweets. We've now got separate hydrocarbons that have all got different uses. Now some of them are more useful than others. You've got things like petrol and diesel. Now in this day and age, we need lots and lots of petrol and diesel, and they're the shorter chains. But you've also got things, these really, really long chains, like bitumen. Now bitumen is great for tarring our roads or putting on our roofs and stuff like that, but actually we don't want to be doing it every day. So we need more of this stuff because everybody needs the petrol and the diesel. People want more and more and more of it, but there's only so much in a barrel of oil. Okay, so when it runs out, we're thinking we're left with these long chains, what are we going to do with them? If you've got a long chain and you want it to be a shorter chain, you've got to crack it. So what we do is we crack the long chains in a process called cracking. So you've got this really, really long chain, and it goes on, and it goes on. And again, you know it's a hydrocarbon because it's made up of hydrogen and carbon only, keyword being only. Okay, we don't want that too long. So what happens is, people go, right, we're going to shorten that chain. The only way they can shorten that chain is by cracking these strong covalent bonds. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, what we do is we apply the conditions. This is something you'll be asking about. The conditions of cracking are high temperature, and a catalyst. Now in the lab, what they would ask us to use is we use porcelain chips or cracked pot, okay? So porcelain chips, or sometimes they call it aluminium oxide. And that is just a catalyst. All that does is speed up the reaction. And when you apply that, it cracks that long chain. And as I said, it's these strong covalent bonds that are broken in the process. What you end up with is something shorter, which is, I'm going to draw a shortened version of it. This is the displayed formula, but you'd end up with a shorter a chemical formula, which is C8, and as it's an alkane, it would be 2 times 8, which is 16, plus 2, which is 18, and that is known as octane. Now octane is something that is commonly found in petrol. That's far more useful for us. Now most of us, if it was you and I, we would say this molecule that's left over at the end here, we'd put it in the bin, but that would be a very, very much a waste. So you've got these lovely useful things, so you're cracking long chains into smaller, more useful, into smaller, more useful chains, and you get something that's left over. That thing that's left over is called an alkene. Okay, so it's not ane, it's ene, and it's got a double bond. Let's put it up here. Okay, so if you've got something like this, this is ethene. Or you might have propene or butene. Okay, so you can see the common thread. If it's an alkene, it ends in ene. If it's an alkane, it ends in ane. All alkenes have double bonds. Okay, now we say these are unsaturated. These long chains with single bonds that are alkanes are saturated. So unsaturated double bonds, okay? So we can test to see that we've made this, and the way in which we test it is with bromine water. Bromine water is orange, And when you react it with an alkene, it attacks the double bond and it turns colourless. If you were to actually put bromine water with an alkane, it would remain orange because there is no double bond to crack. And it's these that we're left over with that we then go on to use in polymerization. That's where we make polymers. What you need to know is you need to know cracking. You're going to do long chains into shorter, more useful ones. You're going to turn the alkanes. You're going to get a shorter chain alkane, which is useful as fuels, but you're also going to end up with an alkene, which all ends in enes, and they react with bromine water, and they turn, we can test for this, because bromine water will turn colourless. Okay, and then we go on to polymerization.